Okay, so very good morning to all of you. So in last lecture, sorry, previously due to internet problem, we are not able to record this lecture. So I'm recording this lecture once again for your purposes. So hope you guys will understood it easily. Okay, so in this lecture, we'll cover the points ejection system. Okay, so ejection system is one of the important mechanism in the molding. Okay, so what happens generally in the molding? We are pressing two molds to each other, and due to that reason, our component or our part get jammed in between that. Uh, Sometimes in the upper mold and sometimes in the lower mold. So what we are doing, we are just uh, by using the injection system, we are removing that part. Okay, so if you observe practically the maximum time what is happening, the part is getting jammed below the in lower mold. So from the lower side, what we are doing, by using the cylinder mechanism, we are just pushing that component or part towards the towards the upside, and we are removing the job. Okay, so this is all about the ejection system. Okay, so for we have different types of molding, that injection molding, blow molding, and many more. Okay, so for each and every molding, we have different mechanisms. Okay, so we'll see. So you don't need to write, so we'll go for the direct next point. Okay, so you guys have already written this all this thing. Okay, so we have different types of ejectors. Okay, so pin ejection, sleeve ejection, valve ejection, air, and stripper. These are the five major ejector systems we are using. Okay, so keep in mind that once again, pin ejection, sleeve ejection, valve ejection, air ejection, and stripper ejection. Okay, so go for the first one, the pin ejection. Okay, so if just observe this diagram toward this pin ejection. So if you see here this diagram, if you see, this is a product. If you see, this is wall thickness of this product, and this mechanism from this side, this mechanism all about the ejection system. Okay, so hope you guys understood. Now I will explain what is happening. This is the ejection system. These two are the pins. You guys are observing here. This is one and this one. This is the top view and this is the side view. You guys are observing. Okay. So what we are doing? This these pins having same diameter or somewhat more, 1 or 2 mm more diameter as compared with its wall thickness. Means suppose our component, our product have a wall thickness 2 mm. Okay, then this product These pins must have a diameter 2 mm. Okay, and what we are doing, if suppose this product is jammed, this is sorry, just wait. Okay, suppose this is our mold, this is our lower mold, and its product is jammed here. And then what we are doing, we are just by using this ejection system, we are just pushing this product towards this upward side. As I have already shown you one mechanism regarding the ejection system. This is how pin ejection system work. In the pin ejection, we have two, three more things. Generally, what we are doing, generally we are using these pins of circular shape, and these pins having circular diameter is equal to the wall thickness of the product. Okay, so this is all about the pin. Okay, and this all theory that I have written this all these points. Okay, so the all these points are just now we have explained. Okay, okay. So this is all about the pin ejection system. Hope you guys have written it. So go for the next one, sleeve ejection system. Okay, sleeve ejection system. Okay, so this is a schematic diagram of sleeve ejection system. This is part, and if you see this, this is the ejector. This is a stepped diameter ejector. Means suppose this is 5 mm diameter. This is 10. This is 15. This is 20. Stepped diameter. Okay, where we are using it? Suppose we are manufacturing the circular rod having inside some hole. Okay, so for such a product, for ejection purposes, we are using it. Suppose this inner diameter is 5, then this diameter will be the 5, and this diameter will be the 10. Okay, and what will happen? Due to this pin will go inside and it will push this part towards the upside. Okay, so this is also simple mechanism. Okay, so I will explain these points once again. The system is used when the part is hollow. Now we are discussed any circular rod having inside some diameter, a hollow hole. Uh, so in some cases, a part having the slot. Okay, for that purposes also we are using this part. Okay, so just in sleeve ejection system, just we have simple part, the uh, stepped diameter. And what we are doing, we are just using one cylinder. How we are using it mechanism, I will show that's once again. Okay, so this is a cylinder and this is a cylinder rod. What I'll do it, we are just pushing the cylinder towards the right side on this side. Okay, so this is how we are using the slew mechanism by using the generally what is happening, the plastic product having maximum weight, we can say 50 kg, not more than in maximum case not more than that, or you can say the 100 kg. For such condition, pneumatic cylinders generally maximum times repair. We don't need to go for hydraulic for plastic product. And in all industry, we are using the uh, pneumatic system, pneumatic ejection system. Okay, so this is a simple ejection system. Only keep in mind that sleeve ejection system we are using just the hollow part or the part having the slots. So like this. Next is a valve ejection system. Okay, so give the heading if you want. Give the heading valve ejection system. Okay, so this is also very important. You can pause the videos, and if you want to draw a diagram once again, you can draw the diagram. Then also no problem. Okay, give the heading valve ejection, and if you want to draw this diagram, uh, you take 1 minute and you can draw. So we'll go for next point. Okay, so this is the pin injection system. This is also very simple. Okay, I will draw how it is practically. So this is cylindrical rod, and this is a cylinder. Okay, what we are doing, we are pushing this part towards the left side by using this pneumatic cylinder. And what is happening due to this? This is a product, and this is whole. This is a slew mechanism. Okay, now what is happening due to this cylinder? This pin, if you observe, this is pin, and here this is a spring. We have used a this. This is a spring, and this is a pin. Okay, so and this is a wall. What are we doing? We are just pushing towards the left side, and due to this, the part will get moved towards the upward and it get removed. And uh, in maximum cases, we are using the two-stroke engine. Maximum cases, we are using the two-stroke engine, and in some cases, uh, we are using the one-stroke engine. The reverse will be the by using the spring. Okay, so here if you see this, the spring is not necessary. Okay, in we have now just look into matter. Okay, I will when the spring is necessary, I will show. Okay, so okay, now once again I will discuss this. Okay, and this is the whole mechanism. Okay, so this is manual mechanism. What we are doing manually, we are pushing this uh, pin towards the upside. Okay, and so that's the reason this is the maximum times it is a pedal mechanism by using the leg. Okay, so that after that this part will get up on upside. The part will get move upside, and when we'll release this force, it will get returned due to this spring. Okay, but in maximum cases, what is happening nowadays? Nobody is interested in the manual work. Okay, so for that reason, what they are using? They are using the two-stroke engine or one-stroke engine. So in one-stroke engine also there is a reverse mechanism is available by using the spring, as we have seen in the FMAP. Okay, so like this. Okay, so this is all about the wall ejection system. Okay, so hope you guys will understood. Next is the air ejection system. Here, air, the word air means, as we know that. Okay, so you just observe this diagram. This is a compressed air. This is a product. Okay, and this is sometimes we can say mm, by pressing this with simple here. If you see compressed air, this is product, and just due to compress, we are attaching here this compressed air by means of uh, MQC wall, MQC wall, and due to this here, this part will get moves toward us the upside. So this is a simple. Okay, and here uh, we suppose the part having weight 10 kg, then by maintaining the uh, area, we can increase or decrease the force. Okay, as we know that how to calculate the force. Okay, while designing the cylinders, we are just calculating the force. Okay, so here also, yeah, as we know that there is a relation between the force, pressure, and air. Okay, so by using these three parameters, here also we can maintain the force. Okay, so such things should not happen. We have used this here the compression part get uh, mm, four part get forced at maximum speed towards the upside, and it get damaged. Such things should not happen. So for that purposes, before designing this mechanism, okay, so before designing this mechanism, we need to study how much force is required uh, as 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 per the our product load. Okay, so if the product is in big size, then of course we need to design the system by considering the big size product. Okay, so this all about the ejection systems. Okay, so as we know that for different application we can use the different ejection system as per the suitability, as per the efficiency, and which is more efficient. Okay, so by considering all these things, we can easily design this, or easily we can establish the ejection system for our molding process. Okay, so in maximum times we are using this ejection system at the bottom mold, but in some cases if part is of circular shape, then in some that cases we need to install this ejection system for the upper side also, and for the lower side also. Okay, so this should be keep in mind. Okay, so this is all about the ejection system. Simple, what we have seen here. Again, I will discuss here. Again, I will once again. So we have what we have seen in this lecture: ejection systems and types of the ejectors. Here, pin ejector uh, for any shape of product, pin ejector system will be easily we can use. Sleeve ejection system, it is only for the hollow part having inside hole, inside the slot. So for such cases, this sleeve ejection system. Next, wall also we can use for any part complicated part, but one condition should match. The part is must be a symmetric in case of the wall ejection system. Okay. After that, here and stripper is a very important that we'll see will in the next lecture. Okay. So guys, that's it for today. Okay.